All right, let's dive right in. We're tackling a massive question today. In a world that is just overflowing with data, how do we turn all of that noise into real, actual insight? Well, the answer is statistics, and we've got the perfect roadmap to show you the way. I mean, think about it. We're just swimming in data, right? Everything from the shows Netflix thinks you'll like to the ads that seem to follow you around the internet. But how does that mess of data actually become a decision? The secret sauce, the engine that powers AI and big data, is statistics. And today we're going to pull back the curtain and show you exactly how it all works. So let's start our journey. First stop, the modern data quest. Look, whether you're in marketing, finance, tech, it doesn't matter anymore. Understanding data isn't just a nice-to-have skill, it's absolutely crucial if you want to make smarter decisions and stay ahead of the game. Okay, so think of our map as having two huge continents. On one side, you've got descriptive statistics. That's all about summarizing and making sense of the data you already have right in front of you. And on the other side, that's inferential statistics. That's the exciting part where you use that data to make educated guesses about the bigger picture. Pretty much everything we're going to talk about today fits into one of these two buckets. All right, like any big adventure, you can't just jump in. You need the right gear. So in this next part, we're going to pack our bags and learn the essential language of statistics. These are the core concepts you absolutely have to know. First thing we need to get straight is the population. Now, this is the big picture, the entire group we're curious about. It could be, I don't know, all the voters in a country, every single car coming off an assembly line, or maybe every potential customer for a new app. This is our ultimate target, the whole enchilada. But let's be real, trying to study an entire population, that's usually impossible. It's way too expensive, takes forever. So what do? We take a sample. It's just a smaller, more manageable slice that represents the whole thing. And by carefully studying this small slice, we can make some incredibly accurate guesses about the entire population. This little idea is the foundation for everything from political polls to clinical trials. Now, this sample we've collected is made of data, and that data basically comes in two main flavors. You've got your quantitative data, and that's just a fancy word for numbers, your height, the temperature outside, how many times you've watched your favorite movie. Then there's qualitative data, which is all about categories, your eye color, the city you live in, your favorite brand of coffee. Knowing which one you're dealing with, that's step one for any analysis. Super important. Okay, foundation is built, our gear is packed. Now we get to the really fun part. Actually using these tools to start mapping out the terrain of the data we've found. This is where descriptive statistics really shines. So, you've got this big pile of numbers. How do you even start to make sense of it? Well, we began by finding the center of it all, using things like the mean, median, and mode. You know, what's the typical value? Then we figure out the spread, using standard deviation. Are all the numbers bunched up together, or are they scattered all over the place? These two things together, they give you a lightning-fast snapshot of what your data looks like. But, you know, just looking at a list of numbers can be, well, pretty boring. And it doesn't always tell you the whole story. That's why we have to visualize it. Charts like histograms and scatter plots, they're not just pretty pictures. Nope. They're amazing tools for spotting patterns, finding weird outliers, and really, truly understanding the story your data's trying to tell you just at a glance.
Okay, so we've gotten pretty good at describing the data we can see, our little sample. But now we're going to do something that feels a bit like magic. We're going to use that small set of clues to make a bold prediction about the entire unseen world. We're going to take a leap into the unknown with inferential statistics.
And this really is the million-dollar question, isn't it? How on earth can a tiny little sample tell us anything reliable about a massive, unseen population? It seems kind of crazy, right? But it's not magic. It's all thanks to one incredibly powerful and beautiful idea. Seriously, the answer to that question is what makes so much of our modern world possible, from scientific research to how companies decide what products to build. It's the bridge that lets us cross from what we know to what we can only guess. And that powerful idea is the central limit theorem. Yeah, it sounds a little intimidating, I know, but the core concept is actually beautiful in its simplicity. It basically says that if you grab enough random samples from any population, it doesn't matter what it looks like, and you average each of those samples, the averages themselves will always form a nice, predictable bell curve. That predictability is everything. It's the secret sauce that lets us be confident in our predictions about the whole population. So that's the theory. But how do we actually use this superpower in the real world? We do it through a process called hypothesis testing. Think of it like the scientific method, but for data. You start with an idea. Say, I think this new website design will get more clicks. You set your rules, you collect the data from a sample, and then you make a decision based on the evidence. It's a really solid, structured way to let the data guide our decisions instead of just our gut feelings.
All right, we've done the hard work. We've climbed the mountain. We get the theory. Now we're at the summit, and this is where we get to see the view. This is where we apply all these skills to solve real, actual problems. It's where data finally becomes discovery.
And one of the coolest tools in our toolkit is something called regression. It's a way to model the relationship between different things. For example, we could use it to ask, hey, if we spend $1 more on ads, how many more sales can we expect to get? See, it's not just about looking backward, it's about making smart predictions about the future. And honestly, that is just scratching the surface. Once you have these skills, you've basically unlocked a set of data superpowers. You can start forecasting future trends, you can A/B test your way to better products, you can find hidden customer groups you never even knew existed. You can even start building your own machine learning models. The sky is literally the limit. You know, there's this quote from Carly Fiorina that just nails it perfectly. The goal is to turn data into information and information into insight. That's exactly the journey we've been on. We started with messy, raw data. We used descriptive stats to organize it into useful information, and then with inferential stats, we turned that information into something truly powerful, insight. So that's the roadmap, the path from raw data to real discovery. We've shown you the way, but the real adventure, well, that's up to you. The world is just packed with data, waiting for someone to unlock its secrets. So the only question left is, what will you discover?